This lesson talks about anti-differentiating, an expression where we have ax plus b all raised to the power of r. But before we do that, let's go back to the chain rule and differentiation so we can make some relationships here. So remember, with calculus and differentiating, if I had an expression like y equals 3x plus 2 all to the power of 4, my derivative will equal this times the power, so 4 times 3 outside 3x plus 2 all to a reduced power. So therefore, we'd end up with 12 outside of 3x. In other words, what we see happening here is my coefficient and my powers combine and multiply to come out the front. And there they are. My expression in the middle stays the same and the power drops down by 1. So there's going to be a very similar circumstance when I integrate and I go back up this way. So what we're going to look out for is me dividing by this figure or multiplying by this figure or multiplying by 1 on this figure, whatever that number is, obviously not necessarily 12, and lifting this power up. So have a look for that in our integration. So what we find is when we take the integral, remember, here's our integral sign of ax plus b to the power of r, or with respect to x, we're going to end up with this factor out the front where we divide by that number, which will be a times r plus 1. That's going to be the new power. In our brackets is the same expression, just like we managed with the chain rule. And our power jumps up by 1. And don't forget, there's going to be a constant. So this is how we're going to manage anti-differentiating. And this is going to work with every single power that there is. So for all r, except if you have a look at this term here, what if r is -1? Then we're going to have 1 over something times 0, and we'll have much sadness because we can't have 0 in the numerator, in the denominator. But what we'll find is actually that's a special case. So now let's investigate when r equals -1. So when r is -1, we've effectively got a case where we're looking at an integral of 1 over some expression to do with it. And if we remember our differentiation again, consider that the derivative of log x equals 1 over x. And so these two are related. What happens is when we have an integral, or we're looking for the antiderivative of 1 over x, we remember this and we're going to get an answer in log form. And don't forget your plus c. Now this straight line business talks all about the fact that my domain for a hyperbola, remember my hyperbola looks like this. My domain for a hyperbola is both positive and negative, but my domain for log x is only positive. So these lines help us manage the mismatch of domains that we come about. And we'll talk about that later. So for now, the two formulas we need to know is the first one, where we have a case of when r doesn't equal -1. And the second case, where if r does equal -1, then my integral of 1 over ax plus b, because remember this is going to be -1 with respect to x, will equal. If you like this or any of my other videos, please subscribe to my channel or like the video. Thanks.